difficult to measure the precise air pressure in a tire because the very act of measuring allows some of the air to escape before the measurement is taken. The air pressure in the tire changes before it can be measured, making it impossible to measure the exact air pressure at the exact moment when you wish to measure it. The exact air pressure in the tire is uncertain. The idea that the act of measuring something can alter the measurement itself has direct application in the Heisenberg uncertainty principle for subatomic particles. The principle says that the position and the velocity of an object cannot both be measured exactly at the same time. At the size of objects seen in everyday life, such as a car, the uncertainty principle has no real application. We can accurately measure both the speed and the location of a car. Because of the car's relatively large size, measurement devices, such as a speedometer, don't alter the result. But at the subatomic level, electrons and other tiny particles can easily be altered in velocity or location by measurement itself. Any attempt to precisely measure the velocity of an electron will knock it about in an unpredictable way, simply because of the connection in nature between particles and waves in subatomic dimensions. Every particle has a wave associated with it. In the case of a simple wave, the electron has a well-defined momentum that is determined by the wavelength. This momentum can be used to determine the electron's velocity. However, we cannot determine the position of the electron because it is equally likely to be at any of the wave's crests or troughs. We can determine the velocity, but not the position. In the case of a complex wave, shown here, some of the undulations of the wave are much larger than the others. This type of wave is made by adding many simple waves with different wavelengths, which means the electron may have many possible velocities. However, the electron is most likely to be found near the position of the high peaks. So this electron is localized. We can determine the position, but not the velocity. Hence, the uncertainty.